Okay, everybody, a little continuation on with the sine law here. How do you find the angles if you're given, how do you solve for a right triangle, not a right triangle, any triangle that is not a right angle. If you're given an angle, its opposite side, and another side, we want to find another angle. So what we know about the sine law, the sine of angle A over 11, sine of A divided by its opposite side is equal to the sine of 100 degrees divided by 20. Sine of 100 divided by 20. Okay, well, the sine of angle A, we find over 11 is equal to, if we find the sine of 100, that works out to 0.9848 to 4 decimals divided by 20. Cross multiplication, the sine of angle A is equal to 11 times 0.9848. All over 20. And when we do that calculation, we end up with a decimal to 4 decimal places of 0.5416. The sine value of angle A is equal to 0.5416. So when we go second function sine, we find that angle A is going to work out to approximately 33 degrees. 33 degrees right over here. Now how do we finish this up? We know that the angle sum of a triangle is 180 degrees. Well, 180 minus 100 minus 33 works up to 47 degrees. So we can find that angle C is 47 degrees. Now we'll use the sine law once again to find the length of the opposite side. Sine of angle C divided by little c is equal to the sine of angle B divided by little b. Okay, for page 483, number 13, you see a diagram here. It says a sailor made the sketch on her navigation chart. How much closer is the ship at S, point S here, to lighthouse A than to lighthouse B? So we're going to have to find the length from S to A and from S to B, and then determine the difference between the two of them. So how do you do this? We've got ourselves a triangle. Right now, we know this angle, angle B, and we know this side. That's all we know about this triangle. But we could find this angle right here, couldn't we? Angle S. We know we've got it between the x and the y-axis, it's 90 degrees. Well, if we take away 10, we can see that that's 10 degrees. So we can take away that 20 degrees. We've got 60 degrees here. Okay. And if that's 60 degrees, we can go 180 minus 60. So what is that, 120? Minus 35, and we can end up getting angle A as well. We can get all three angles here. Then we can find these side lengths. So for instance, if I want to find from here to here, I'll go, sine of 35 degrees all over, let's call it little b, is equal to the sine of 60 degrees divided by 11. And we'll use the sine law to finish it up.